Tonight's video is day 2 of section 5.1, which is natural logarithmic function differentiation. Again, as yesterday's video, the problems are pretty difficult. Even though we have worked with differentiation with natural logs already, these aren't easy. So what I'm going to do is, out of your homework problems, I'm going to go ahead and I'm going to actually do 4 of them completely for you. And those are still required in your homework along with the ones I did not do. So the first one I'm going to do is number 80. And 80 asks us to use implicit differentiation to find an equation of the tangent line to the graph at the given point. To find equation of tangent line to the function at given point. We haven't heard that phrase in a little bit. So let's write down what number 80 looks like. 80 is y squared plus natural log of x times y equals 2, and it's at E1. So let's use implicit differentiation. So I keep this thing focused. So that's 2y dy dx plus 1 over x times y, chain rule, 1 times y plus x dy dx equals 0. So again, the differentiation of natural log is 1 over that, but now we have to take the chain rule, which means now I'm going to take the derivative of this, and so that is your product rule. So let's go ahead and clean this up. So I distributed that, canceled out the y's. I'm going to distribute this, cancel out the x's. Right, so the x's cancel, I have 1 over y, dy dx left. So let's go ahead and let's gather our dy dx. That's 2y plus 1 over y equals negative 1 over x, put that to the other side. Dy dx, let me scoot this up, equals negative 1 over x. I'm going to go ahead and, well, let me go ahead and find a common denominator first. Maybe we want to do that. Now let's do dy dx multiplied by the reciprocal. Okay, so now we have that there. Let's see, let's go ahead and combine this a little bit more. I'm going to go ahead and, again, what am I doing? I used implicit differentiation, yeah, to find what? Oh yeah, the equation of the tangent line to the function at the given point E1. So let's do this at E1, in which x is E and y is 1. Right. y is 1, x is e, y is 1, x is e. So what is that? That's the derivative at that point. So that means that is the slope. Remember, e is just a number, 2.71. So that's y minus 1 equals the slope negative 1 over 3e x minus e. So they might leave it like this. Maybe I'll leave the x separate. There's the equation of the tangent line to the function, original function, at the point E1. This is the original function, and I had to use implicit differentiation. So that's some good review with some difficult mathematics. So I did number 80. Oops. Let's do the next one. The next one will be 82. So this is going to be a long video tonight, sorry. But I am not there again tomorrow. So hopefully you'll appreciate this. Let's see what 82's directions are. It says, show that this function is a solution to the differential equation. And so the differential equation happens to be x plus y minus x dy dx equals 0. Again, show that the function is a solution to the differential equation. So what I'm going to do is I'm going to proceed to take the derivative of this. Once I take the derivative of this, then I'm going to go ahead and substitute that derivative into here and see if it is a solution. Dy dx equals, well, that's the product rule. So I did that piece right here, minus 4. Okay, so I have found the derivative. Now I'm going to check to see if it's a solution. So I'm going to substitute this piece in here. So I'm going to check. So I'm copying x plus y minus x, natural x minus 3 equals 0. So I took that from here. I'm checking to see if both sides are equal to 0. Obviously this side is 0. Let me see if this can be 0. Now I have a y in here. I have all these x's and I have a y. So for this y, I'm going to substitute in this complete unit, so I have all x's. So I just substituted that y. Now I have all x. Now I can combine like terms. Let's see. So positive x, natural log of x, negative x, natural log of x. Those two cancel. I have a negative 4x. Is that what I'm supposed to have? Let's see, I do not think I distributed that right. There we go. And so that goes here. So that is a 3x. See, 3x and x, that's 4x. It's a negative 4x. Those cancel. So it is 0. That works. That's 82. Let's proceed on to the third problem. It's 84. '84's directions. I'm supposed to locate any extrema. Well, I find those on the second derivative. An extrema is my original derivatives, relative mins and relative maxes. And I'm supposed to find any inflection points. And where do I find those? On the second derivative. Excuse me. So 84. Y equals x minus natural log of x. So the first thing I want to denote is my domain here. This value here for x, on my natural log of x, it has to be greater than 0. Remember when you graph out the natural log of x, that parent function? Here's my asymptote. And so my x values have to be greater than 0. They cannot even be 0. So just want to denote that. I might need that in order to figure out extrema and points of inflection. I'm going to go ahead and take that first derivative. In fact, I'm going to use y prime. 1 minus 1 over x. And so I'm looking for extrema. That means I'm going to set this equal to 0. See what it takes to make that equal to 0. So let's see, 1 over x equals 1. And so when x equals 1, that's when those two sides will be equal. So this is for y prime. 1. Remember, my domain, my x values are from 0 and above. So I can't go past 0. So my test point is going to be 1/2, but my test point can be 2. And so I'm going to put 1/2 into this equation. So what is that? That is 1 minus 1 over 1/2. That's really 1 minus 2. That's negative. I'm going to put in 2. 1 minus 1, that happens to be positive. So at x equal 1, on y, there is a relative min. And it goes from negative to positive when it's cupped down from negative to positive. And let's go ahead and let's find that complete point, not just at what x value. So how do I find that ordered pair? At what ordered pair? Well, I know the x value is 1. How do I get the y? I just put it back in the original equation. 1 minus natural log of, so let's see, 1 minus natural log of 1. And e to what power is 1? That's 0. So 1 minus 0. And so that happens to be at 1, 1. That's where it happens. That's where I have a relative min. Let's go check on points of inflection. I need to go take the second derivative. The second derivative, let's go back and find our y prime. There it is. So I'm going to take the derivative of 1, that's 0. I'm going to take the derivative of this. So let's see. That would be, let's rewrite this. 1 minus x to the negative 1, correct? So the derivative of that is going to be 0. In fact, I'll write down 0. Put down that minus sign. Bring down that negative 1. And then I'm going to decrease this, bx negative 2. So that second derivative, first off, that's positive, so it's going to be 1 over x squared. And so when I set this equal to 0, there is no value. And remember, when we find points of inflection, we don't look to see where it does not exist. That's only for relative min and max. So therefore, there are no points of inflection. That's number 84. The last problem that I'm going to do is is number 97. Number 97 looks like this. Y equals x times x minus 1 to the 3/2 power all over the square root of x plus 1. Now in the second set of problems, there's one set of directions, and it says use logarithmic differentiation to find dy dx. So you use log differentiation to find dy dx. Well, there are no logs. What does it mean use logarithmic differentiation? So again, you can look in the textbook in 5.1. You can always take a look in the textbook. There are additional problems than the ones I just do in your notes. And so what it means is I'm going to go and use a technique back in pre-calculus. I'm going to go ahead and take the natural log of both sides. And that will help me deal with this complicated piece. I'm going to go ahead and take the natural log of both sides. And I'm sure you're thinking that just complicated it more. So what I can do is I can first use the quotient property. Next, I can use the product property. Next, I'm going to put a 2 there, sorry. Next, I'm going to use the power rule. Oops, and look at this one here. Isn't square root of x plus 1 really x plus 1 to the 1/2? So I'm going to use the power rule here also. Oh, and I put a plus. It's supposed to be a minus. 1/2 natural log of x plus 1. Right, that's what earlier this is. I'm going to bring down the 1/2. So now I'm ready. And here comes the dy dx, because look at, I have a y here when I go and take the derivative. So I'm going to use implicit differentiation. So I take the derivative of this that has a y in it. It's 1 over y dy dx. So I'm going to solve for dy dx. Equals, well, that's just 1 over x. Put my 3/2. That's just 1 over x minus 1. Minus, put my 1/2. And again, I'm sorry, x minus 1, and then I'm supposed to take the chain rule and find the derivative of x minus 1. It happens to be just 1. And then this one here, I've done the 1/2. Take the derivative of this. It's 1 over x plus 1, and then derivative of the inside. Chain rule is just a 1. Sorry, I went a little bit too fast there. And so I need to find dy dx. I'm going to go ahead and multiply both sides by y. And I'm going to go ahead and take this, and I'm going to clean this up so I can see it. Now let me proceed from here. What I'm going to do is I'm going to substitute for y the original function. Right, that's y. And then at the same time I'm going to find a common denominator. My common denominator is 2x, x minus 1, x plus 1. And so this one here needs to be, this one needs to be multiplied by a 2. And an x minus 1 and an x plus 1. Bring down this plus, take the 3. So what is that? What do I need here? I need to multiply by an x and an x plus 1. X and an x plus 1 minus, and this is just times by a 1. So what do I have? The 2 and the x plus 1. So I need to multiply by x and x minus 1. So this is being multiplied to this. I'm going to go ahead and start canceling here if I can. Here's x minus 1, just like there's a full one and a square root. Here is a full one, so if I can cancel that 1 and have a square root left. X times x minus 1. And then this square root of x plus 1 and this x plus 1, so that's 1 on the exponent, and that's a 1/2. So let's gather those to put x plus 1 to the 3/2. So I've taken care of this, I've taken care of this. Let me copy the 2x underneath. I see I can cancel out those x's too. Right? So I'm leaving that alone, and I'm cross-canceling, or I'm multiplying straight across. So I took care of this here, and then I did these two. There's 1 and 1/2. So I just add those, and then I have an x and a 2x left, and I can see those x's are going to cancel. So what do I have left? Just the numerator. So I'm going to start multiplying that. Continue to clean this up. Oops. Let's see what I have here. Maybe I'll do it on the next line. So let's see. I have 5 minus 1 of 4x squared. X is I have 3 and a 1. And then I just have a minus 2. And so I can factor out a 2 and cancel it with that 2. Fun? How about more like, ouch? Thank you.